Hey everyone, this is lesson 3 of our Unit 7 mole unit. Today we're going to learn how to convert between moles and particles, and then we're going to learn how to convert between mass and particles, grams and particles. All right, so just like last time, you need a periodic table nearby. You also need a calculator. Specifically, a scientific calculator would be best. I wouldn't use the calculator on your phone because we're going to be using that E button, that exponent button. So you can download free apps on your iPhone or your Android, whatever type of phone you have. You can download scientific calculator apps. And it'll do the same function as a normal scientific calculator. All right, so starting on the back of your note sheet, this question says, how many atoms are in 20 moles of aluminum? All right, so what do we know? We know we have 20 moles. What do we not know? We don't know how many atoms that is. So next to moles, I'm going to write 20. Next to atoms, I'm going to write a question mark. Now notice, in this problem, there have been no mention of grams or mass. So we don't need to know the molar mass of aluminum. Anytime you are converting to atoms, you just need to use Avogadro's number, which is 6.022 times 10 to the 23rd. So for our conversion, we're going to start with what we know. We're going to start with 20 moles. We want to get rid of moles, so we move it to the bottom, and we put atoms on top. So next to atoms is where we're going to put Avogadro's number. And next to mole, we always put 1. Notice that on the previous problem, we also put 1 next to mole. So you are multiplying 20 times Avogadro's number. And I want to show you how to plug that in because you're going to be using your E button. So 20 times 6.022, and this is the part where you use your E button. On my calculator, it's a second function. On your calculator, it might just be a clear button, double E, or at the bottom it might say EXP. But either way, you're not going to type times or 10. You're only going to type in 6.022, press that E button, and then 23. And then when you press enter, you get 1.2044E25. We can round that to 1.2 times 10 to the 25th. That's what that E button means, times 10. And in this case, to the 25th power. So that's how many atoms are equal to 20 moles. All right, for the next problem, we're going to be doing the opposite. This time we have 5 times 10 to the 22 molecules of water. How many moles is that? So we know this is how many molecules we have. We don't know how many moles that is. So next to moles, I'm going to write a question mark. Next to molecules, I'm going to write 5 times 10 to the 22nd. Once again, nothing has been said about grams or mass, so we don't need to use the molar mass. We're just going to use Avogadro's number. And it doesn't matter if, notice in the first example, we were talking about atoms. Now we're talking about molecules. That just all falls under the category of particles. All right, so don't worry about, get caught up with the terminology. We're still talking about particles. So starting with what we know, we have 5 times 10 to the 22nd molecules. I want to get rid of molecules, so I'm going to move it to the bottom. I'm solving for moles, so I'm going to put that on top. I always put 1 next to mole, and next to molecules, I put 6.022 times 10 to the 23rd. So this time I'm dividing. This number times 1 divided by 6.022 times 10 to the 23rd. I'm going to plug that in for you. 5 E22 divided by 6.022 E23. And I get 0.083 moles. And that's my answer. All right, so that's how you convert between moles and particles. Now we're going to finish up our notes today by talking about how you can convert between grams and particles. So for this problem, it says you have 25 grams of C2H4. How many molecules is that? So we know we have 25 grams. We don't know how many molecules that is. Now, we haven't gone from grams all the way to molecules. We've gone from grams to moles, and we've gone from molecules to moles, but we've never gone from one to the other. And you can't. You have to convert to moles first. So that's what this little note is telling you. Whenever you're going between mass and particles, convert to moles first. So we're going to fill in a few things. Next to mass, we're going to write 25 grams. And since this problem does mention grams, it does mention mass, we do need to find the molar mass. I'm going to go ahead and do that. There are 2 carbons, 4 hydrogens. If you look back at your periodic table, hydrogen's mass is 1. Carbon's mass is 12. There we go. So I get 24 and 4. Add those together, I get 28 grams per mole. All right, so now we can go ahead and convert to moles. So starting with the 25 grams, I move grams to the bottom, moles on top. 28 is my molar mass. That goes next to grams. 1 goes next to mole. So I'm taking 25 and I'm dividing by 28. And I get 0.89 moles. I can plug that in here. Now I'm not done because I still need to solve for molecules. So now I'm going to take my moles, and that's where I need Avogadro's number to convert moles to molecules. So 0.89 moles. I'm going to move moles to the bottom, molecules goes on top. I plug in Avogadro's number, 6.022 times 10 to the 23rd. And next to mole, I put a 1. And now I'm just going to multiply those 2 numbers. 0.89 times 6.022 second E23rd. And I get 5.4 times 10 to the 23rd molecules. Okay, now we could have done all of that in one step. So you could have, rather than stopping here and solving for moles, you could have just divided by 28 and then multiplied by Avogadro's number. I just wanted to show you that you have to convert to moles before you can convert to molecules. Now, another thing we're going to do today is create a flow chart. It doesn't really matter where you write this flow chart. Normally, I have you write it on a piece of construction paper, but if you want to keep all your notes together, you might just want to write it at the top of the front of this sheet. So dimensional analysis is always my preferred method of solving problems, but this flow chart, I've found that a lot of students prefer to see it this way. So whatever floats your boat, I'm gonna give it to you and you can choose what method you want to use. So if we are going from grams to moles, we have to divide by the molar mass. And if we're doing the opposite of that, if we are converting moles back to grams, we have to multiply by the molar mass. So grams to moles, you know grams, you don't know moles. You start here, follow this top arrow, you divide by the molar mass. Moles back to grams, so you know the moles, you're solving for grams, you multiply by the molar mass. Now, if we want to go from moles to particles, and remember particles can mean atoms or molecules. So moles to particles, we multiply. This time it's by Avogadro's number. And if you're going from particles back to moles, you're going to divide by Avogadro's number. So what I want you to notice is this problem, this last problem we just did together, how we followed the flow chart. We knew how many grams we had. So starting on the flow chart, we're starting here. We did not know how many molecules that was. So we were starting at grams and going all the way over to particles. All right, and you might want to make yourself a note that particles can mean atoms or molecules. Okay, so going from grams to particles, I'm following these two top arrows, which means first I'm going to divide by the molar mass, and that's what we did here, 25 divided by 28. And then following this second top arrow, we're going to multiply by Avogadro's number, and that's what we did here. So again, whatever method works better for you, you have the liberty to choose. Now, the next assignment that you're going to be doing is a color by mole assignment. So you're going to go through this packet and you're going to do a lot of converting, but each of these you're converting whatever this number is, you're converting it into moles. One thing I do want to show you, because we haven't covered this, is this conversion right here. Some of these are in liters and you're supposed to convert liters to moles. For any of those problems, like problem number 1, all you have to do is divide that number by this, 22.4, okay, to get your answer. So you'll notice, like down for number 4, same thing. Anytime you see liters, just divide by 22.4 to get your answer. Okay, and then you're going to use this sheet to identify the color. So for instance, this first one, 22.4 divided by 22.4 gives me 1. The color for 1 is red. Boom, I'm done with problem number 1. So I do want you to show your work. I would put a box around that. To get full credit, you do need to show your work. But showing your work can be as simple as what I've done here. Multiply or divide by whatever number you're needing to multiply or divide by, and then writing the color that matches that. Now, I know we all have different resources. I don't know if you have markers, colored pencils, or crayons at your house, so you may not be able to physically color this mole, this picture here. So all you have to do is the worksheet that goes along with this, showing your work, writing the color down. But if you do have the resources and you want to color this picture, I will award extra credit for that. So again, let me know if you have any questions.